In question 5a, we're to state Newton's second law of motion. Well, this is that the resultant force is directly proportional to the rate of change of momentum. In B part 1, we're to calculate the momentum of a tennis ball as it hits the ground. Well, momentum is given by mass times velocity, and we have a mass of 0.062 kilograms times a velocity of 14 meters per second gives 0.87 Newton seconds. In part 2, we're to determine the speed of the tennis ball as it leaves the ground. We have a force against time graph, and we know that impulse, which is force times time, is equal to the change in momentum. And this is mass times change in velocity, as mass times velocity is momentum and the mass won't change, it has to be the velocity that changes. So we can rearrange to get the change in velocity is equal to the impulse, or force times time, over the mass. And the force times time is the area under the graph. Obviously divided by the mass then. And we have a triangle, so that is half base times height, which is a half times 0.18 times a height of 17, the mass of 0.062 gives a change of speed of 24.7 meters per second. It initially had a speed of 14, so if we have 24.7 minus 14, we get a new speed of 10.7 or 11 meters per second. In part 3, we're to state what is meant by an elastic collision and how our answer shows that this is not elastic. Well, in an elastic collision, kinetic energy is conserved. And here, speed changes, so kinetic energy changes. So it is not an elastic collision.